Number 14, A. What are dipole-dipole forces? Well, dipole-dipole forces are forces of attraction between polar molecules. We see dipoles, right? When we have dipole-dipole, it's a two-ended object, hence dipole. Right? It's a two-ended object. Here we're referring to a partial positive end and a partial negative end. So we have two different two-ended items. So we say it twice, dipole-dipole. Right? We have two different objects that have a partial positive end and a partial negative end. That's two polar molecules. And when the partial negative end lines up with the partial positive end, that's an attraction. Right? We call that a dipole-dipole force. But what is going to determine the polarity of a molecule? Well, it's actually going to be two things. The polarity of a molecule, not just a bond. Okay, number 13 was asking about the polarity of an individual bond. Here in 14, we're asking about the molecule as a whole. There are two things. The polarity of a molecule is determined by the polarity of the individual bonds within the molecule, as well as the orientation of those bonds with respect to each other. We can have a polar bond, right? Two atoms within the molecule be bonded polarly, right, and have a polar bond. But if there is an identical polar bond oriented the other way within the molecule, then there will be it'll be nonpolar. Okay, there won't be a partial positive end and a partial negative end. It'll send those polar bonds will be offset or balanced out by one another because they're opposite in orientation.